This is the Chapter 2 review. The very first section had to do with solving systems of equations with two variables. Of course, the purpose behind this is to find the intersection between two equations or two lines. Another way of saying that is you're finding the x and the y that works in both equations. There's different types of systems. There's an inconsistent system, which says it has no solution. These are parallel lines that never crossed. So when they ask you to find the solution, you're looking for what they have in common. An inconsistent system would have nothing in common. A consistent system can either be independent, that they cross at one point, or dependent, they cross at all points. In other words, they're the same line. So you have to be able to make sure that you can classify a system of equations once you've solved it as to either whether it be inconsistent, consistent and independent, or consistent and dependent. We talked about different ways to solve it. You can solve something graphically by using your graphing calculator to verify the accuracy once you've graphed it. You can solve systems of equations algebraically by doing either elimination or substitution. And then you can solve a system of equations by doing a matrix that we learned later on in the chapter. So we're going to actually work through these. We'll solve this system, and we solve it in various ways. Let's solve it by graphing first. So of course, by graphing, we would need to rearrange this so that we have it in y equals mx, as I put it, mx plus b form. So I have y is equal to 3x minus 10. And then on this one, I would have y is equal to negative 1/4 x plus 3. So those are the two things that I would need to graph. I'm going to go down 10. And then I'll go up 3 and over to the right 1. And then this one I'm going to go up 3. And then I'll go down 4 and over to the right 1, 2, 3, 4. So what I'm trying to figure out is that point right there. Now if you've done it on graph paper, then you probably could have a pretty good idea what that point is. But you do this by hand, but then to back it up, what you're going to want to do is you're going to input both of those equations in your calculator under y equals, and then you're going to go second calculate. You're going to go down to number 5, which is intersection, and you'll keep hitting enter until it says intersection, and it gives me the point of intersection here at 4, 2. Now with these, you can always check to see if they're right by plugging them in and making sure it works in both points, in both equations. So that's one way to do it. We could also do it by substitution. Now, when we do it by substitution, one of these we're going to take and make a key. So I'm actually going to take this first one and I solve for y, and I get y is equal to 3x minus 10. And this becomes the key that I plug into the other one. So this x plus 4, I'm going to, rather than write y, I'm going to write what y is equal to. And then I'm going to solve it. So I have x plus 12x minus 40 equals 12. And I'm going to add the 40 and add these two. So I get 13x is equal to 52. When I divide, I get x is equal to 4. Then I would take that and plug it back into the key. So I have y is equal to 3 times 4 minus 10, which is going to give me an answer of 2 for the y. Same thing I got up here when I did it by graphing. So this is graphing This is substitution. We'll do elimination. Look back at that equation. So I have 3x minus y equals 10 and x plus 4y equals 12. Now you can decide which one you want to eliminate. I'm going to eliminate out the y. So I'm going to multiply the top one by 4, which is going to give me 12x minus 4y equals 40. Remember, you're trying to match up the coefficients, but have them have opposite signs, which is what I have on the y. I have a -4 and a +4, which means those eliminate out each other. So I have 12 plus 1, which is 13. 52. I'm going to divide by the 13, and I'm going to get x is equal to 4. Then I would have to plug back in one of these, doesn't matter which one. Let's plug into this one. So I have 4 plus 4y equals 12. Subtract the 4, so I have 4y is equal to 8, and y is equal to 2. So again, you have x is equal to 4, y is equal to 2. The only other one we did matrix, and if you remember on this, you put it in matrix form by grabbing the coefficients. Now, you've got to have the x's lined up and the y's lined up to do that. So this would be matrix form of that particular system of equations. If I made this matrix A and I made this matrix B, then when I go to solve it in my calculator, I know that x, y is equal to the inverse of matrix A, which you're going to do on your calculator, times matrix B. And that right there would give me the answer. And what it will give me is it will give me this answer. And remember, there's a 1-to-1 correspondence when there's an equal sign between them. So I know that x is equal to 4 and y is equal to 2. So we've done this actually 4 different ways and got the same answer all 4 ways. The test may or may not ask you which way to do it. So you got to be able to do it all 4 ways. All right, section 2.2, solving systems of equation was 3 variables. This is one where we have to put 2 equations together and eliminate out, and 2 equations together and eliminate out. Put those 2 together and work through that to eliminate out another variable so that eventually you can solve for 1. Now, I put on here with and without using a matrix. Yes, you can put them into your calculator. So this would be in the calculator. You want to go 4, 2, -7, 1, -3, 2, 2, -4, 3. And we would call that matrix A, and it's being multiplied by x, y, and z. And it equals your answers, -8, 4, and 2. If I call that matrix B, again, my x, y, and z would equal the inverse of matrix A. Now remember, there is order to this. That's why I have to do the inverse of matrix A first. Okay, and that's going to give you the answer. Okay, we learned that later in the chapter. In section 2.2, we actually learned this by elimination. So we're going to work through this down here. I'm going to do it in pencil just in case I make a mistake. I think what we'll do is we'll solve for the y. So I'm going to put the first 2 together. And I'm going to multiply this top one by 3. So that gives me 12x plus 3y plus 6z equals negative 24. I'll bring this one straight over. 2x minus 3y minus 4z equals 4. Then I'm going to add those. I should eliminate something out, so this is going to give me 14x plus 2z equals negative 20. And I'm going to circle that because I'm going to come back to that. Okay, notice that it's not down to one variable, so I still can't solve for it. So now I put two other ones together, and I'm gonna choose the first one and the last one, and I have to eliminate out the same thing I eliminated out here. So the y's got to go away. So I'm going to do 4x plus y plus 2z equals negative 8, and I have negative 7x plus 2y plus 3z equals 2. And I'm going to multiply this first one by negative 2 because that's going to match up the coefficients in front of the y. So that's going to give me negative 8x plus a negative 2y plus a negative 4z equals positive 16. And this one I'm just going to bring straight over. Okay, when I do that, I'm going to get a negative 15x plus negative z is equal to 18. And I'm going to circle that one. Now I'm going to put these two together. So I've got 14x plus 2z equals negative 20. And I have negative 15x plus negative z equals 18. I'm going to multiply this one by 2 and bring this one straight over. So I have 14x plus 2z equals negative 20. And this is going to be negative 30x plus negative 2z equals 36. I'm going to add this. The z's go away. That's going to give me negative 16x is equal to positive 16. So when I divide, I get x is equal to negative 1. Okay, so I've got x is equal to negative 1. I've got to solve for the y and the z. So I'm going to take that negative 1 and I'm going to plug it back into one of those circled equations. Doesn't matter which one. So let's say I do this one. I might use the other paper here. Let me just do it this way so we have extra room. Okay, so I have 14 times negative 1 plus 2x or 2z equals negative 20. So I have negative 14 plus 2z equals negative 20. I'm going to add the 14 to both sides, and when I do, I get a negative 8. Then I'm going to divide and get a negative 4. So now I've got z equals negative 4. So now I take the negative 1 and the negative 4 and I plug it back in to one of these equations. So let me do that. I have 4 times a negative 1 because I solved for the x plus y, which I still don't know, plus 2 times negative 4, which is the answer to z, equals negative 8. Now all I have to do is solve for the y. So I have negative 4 plus y equals negative 8. Should be plus right there. Equals negative 8. So this is going to give me a y plus negative 12 equals negative 8. I'm going to add 12 to both sides and I'm going to get y equals 4. Okay. All right. And section 2-3, we worked on matrices. We worked about scalar multiplication. We worked about on addition. We worked on subtraction. We worked on multiplication. Any of these can be done in your calculator. You can do them by hand or you can do them on a calculator. If I said I want to know what matrix A plus matrix B is equal to, remember, in order to add two matrices, they have to have the same dimensions. This one is a 2 by 2, so 2 rows, 2 columns. This one's a 2 by 2, so 2 rows, 2 columns. So to add them, I just add like first row, first column term plus first row, first column term. So the answer here would be positive 1, 18, 10, and 12. Now, on addition and subtraction, it's very likely that you'll decide not to put the matrix into your calculator because it's actually quicker to do it without doing it. If I did A minus B, then I do the same thing that I just did up here, but I subtract. So the answer there is going to be negative 5 minus 6, which is negative 11, 6 minus 12, which is negative 6, 0 minus 10, which is negative 10, and 12 minus 0, which is 12. So we've looked at this, we've looked at this. Scalar multiplication is simply if you have a number in front of your matrix, like let's say I've got matrix A, and I've got a 4 in front of it, I am simply going to multiply, almost like I'm distributing, to get my new number. So 4 times negative 5 is negative 20. 4 times 6 is 24. 4 times 0 is 0. And 4 times 12 is 48. So it's almost like distributive property. Now, multiplication is the one thing that I would suggest you do in your calculator. I'm going to do this one for you out, but I think you're going to find that it's easier to do in your calculator than to do it by hand. But just to refresh your memory on how to do it, okay, so let's say I'm multiplying those two matrices. It's row times column. Now, to multiply, remember the dimension issue. The center terms on their dimensions have to match. The resulting matrix is going to be the first and the last term. So this is going to give me a 2 by 2 matrix. I'm going to go negative 5 times 6 plus 6 times 10. So this times this plus this times this. Then I'm going to come over here to the second column and I'm going to go negative 5 times 12 plus 6 times 0. Then I'm going to come down here to the bottom row and I'm going to go 0 times 6 plus 12 times 10. So this times this plus this times this. Then I'm going to come to the second column, 0 times 12 plus 12 times 0. So my resulting matrix, I'm going to add those together, which is going to give me a negative 30. I'm going to multiply those together, plus 60. So I'm going to get a 30 right here. This is going to give me a 0. This is going to give me 120. So I get 120 right there. 0 plus 120. This is going to give me a negative 60 plus 0. So I get a negative 60 here. And this is going to give me a 0 plus a 0. So I'm going to get a 0 there. So when I multiply A times B, I'm going to get that matrix. Again, I believe the multiplication, it might be worth it to put it into your calculator. We use the matrices in some situations with transformations, but we talked about the fact that there was transformations that were easier to do without the matrix. So reflection, if you're reflecting over the x, what happens is you take the opposite of the y. The x stays the same, the y becomes the opposite. If you're doing it over the y, the x becomes the opposite and the y stays the same. And if you're doing it over y equals x, they actually switch positions. So if I'm going to reflect this over the y equals x, what I'm going to do to get my A prime, my B prime, and my C prime is I am going to switch the position of those. So it becomes 2, -1. I just switched the x and the y. It becomes 0, 2, and it becomes -1, 0. Then all you have to do is graph it. So I have the point 2, -1, so that's A prime. Then I have 0, 2, which is B prime. And I have -1, 0. Oh, -1, 0, right there, is C prime. Now, the actual y equals x line is that line right there. And so you can see that the blue has just reflected over the pencil. So I reflected it over the y equals x, which is the green line. We also talked about translations. Translations were also called slides. And these can be done with a matrix, but it would be easier to do it just by hand. So let's say I want to translate ABC, this triangle, 2 units left and 1 unit up. Well, left affects the x. If I go left, I'm going to go at a negative. So I'm going to add a -2 to my x values. So let's do that. So A prime, B prime, and C prime. If I add a -2, I get a -3. If I add a -2 to the x, I get a 0, and then I get a -2. Then it says 1 unit up. Up and down affects the y. If I'm going to go up, it's positive. If I'm going to go down, it's negative. So if I go up, I'm going to add a +1 to the y values. So that becomes 3, that becomes 1, and that becomes 0. So now I'm going to graph those. I have the point -3, 3, which is A prime. 0, 1 is B prime. And -2, 0 is C prime. So I have this triangle. And you can see it just moved up 2 and over, or up 1 and over 2. Okay, so I just slid it. Or you could say 2 to the left and 1 up. It doesn't matter which one you do first. All right, this is dilating something by a factor of 2. It makes it bigger. If I wanted to make it smaller, I might dilate it by a factor of 1/2. What happens on this is I multiply everything I have by that factor. So A prime becomes -2, 4. B prime becomes 4, 0. And C prime becomes 0, -2. So my new points, I have -2, 4, which is my A prime. I have 4, 0, which is my B prime. And then I have 0, -2, which is my C prime. So you can see that it expanded it twice the size. So dilation can be smaller or greater. Now, the one that I would suggest that you use your matrix for would be the rotation matrices. You will find them in your book on page 91, so make sure you have them recorded somewhere as a matrix. You might want to do it as JKL in your matrix on your calculator. So make sure you've got those 90, 180, and 270 rotation matrices recorded in your calculator. So if I was going to do this, now notice I used the same points as I used before, but here's my x, here's my y, here's my x, here's my y, here's my x, here's my y. So I want to put those into my calculator, and I will put, let's see, give me a second. I want to do this as matrix A. So matrix A is a 2 by 3. Then I got to put my points in there, -1, 2, 0, and 2, 0, -1. And then I'm actually going to put this matrix in as B because I don't have them recorded in there. So I'm going to edit matrix B, and now it's a 2 by 2. And I'm going to put that one in. So 0, -1, 1, and 0. So I'm going to select my matrix B, which is what I gave this one, and I'm going to multiply it by matrix A, which is what I gave this one. I assigned that one to, and it's going to give me this resulting matrix: -2, -1, 0, 2, and 1, 0. Now, this is going to be my A prime, this is going to be my B prime, and this is going to be my C prime. So I have -2, -1, so that's going to be my A prime. Then I have 0, 2, that's going to be my B prime, and then I have 1, 0, which is going to be my C prime. Now, hopefully what you see is it's just turned it about the origin. It's rotated it 90 degrees counterclockwise about the origin. 2, 5, we basically used our calculators for most of that, and your calculator can be used for all of it except for finding the inverse of the third order matrix. So I'm going to go through this and talk about how you can do it by hand and how you can do it in the calculator. Okay, 5 times 0 is 0, so I'm multiplying up. 3 times -2 is -6, and then I subtract those, which gives me a +6. So that's the determinant. That's the number that represents that matrix. Notice this is like parallel lines. If they want to find the determinant of it, it almost looks like the absolute value signs. It doesn't have the shoulders and the feet of just a normal matrix. If I put it in my calculator, I would put this into like matrix A. Then I would select matrix A, and I would select this button, x to the negative first power, which then, oh no, I'm sorry, I'm giving you the inverse. Forget that. Okay. Okay, let's do the inverse then and not the determinant. If I went to put this in the calculator as the determinant, I go to matrix, I go over to the right one, which is math. The first one down is determinant, and I would select matrix A, and it would give me 6. Okay, so back over here for the inverse matrix. If I put that in the calculator, it's the same as selecting the matrix and then selecting that button. But let's do it by hand. Okay. The way you find the inverse of a second order matrix, and by the way, you can't find the determinant or the inverse unless the matrix is square. So it's 1 over the determinant of that matrix, which we already just found. Okay, I already know that the determinant of that is 6 times, and then there's a pattern here. You're multiplying it, you're switching these two, so 0, 5, and you're taking the opposite, so that becomes negative, and that becomes positive. So my inverse matrix would be 0, and then I would have 2 over 6, which is 1/3, and I would have -3 over 6, which is -1/2, and I would have 5 over 6. So this right here is the inverse of that matrix. Now what that means is, if this was matrix A, and this is the inverse of matrix A, if I multiplied them together, what I would get is the identity matrix. So it's almost like saying 4 times -1/4 is equal to 1. Matrix times its inverse is equal to the identity matrix, or in a way, the 1 of a matrix. Now, third order matrix, which is a 3 by 3, you can do these by diagonals, expansion of minors, or the calculator. So let's do it by, I don't know, let me do down here by the expansion of minors. I'm going to take 5 and I'm going to multiply it by the determinant of the expansion of its minors. So I'm marking out the row and the column it's in, leaving me with 3, 4, 2, and 2, minus, then I take that number, -2, times the determinant of its expansion of minors. So I mark out this row and this column. So I'm left with 4, -1, 2, and 2, plus this times the expansion of its minors, which would be 4, 3, -1, and 4. Okay, so this determinant would be 6 minus 8. So that's going to give me a -2 times my 5. So I have a -10 right there. This is going to be plus 2, and I'm going to multiply up. So I have 8, and I have a -2, and I'm going to subtract. So that's going to be 10 times 2, which is going to give me a 20. Okay, +10 times a +2. And then this one's nice because it's 0 times, and I don't even care what this one is, even though we can do it. The determinant of that would be 19, but I'm taking 0 times it, so I'm going to get a +10 right here. Okay, if I did it by diagonals, I have to recopy the first 2 columns, and then I have to multiply up. So when I multiply up there, that's going to give me a 30. When I multiply up here, that's going to give me a +4. And when I multiply up there, it's going to give me a 0. Then I'm going to add those. So I'm going to get a 34 up here at the top. Okay? Then I'm going to do diagonals down. And I'm going to do the same thing. So I have 0, and that's going to give me a 20 times 2, which is going to be a 40. And then this one's going to give me a -4. Wait a minute, something messed up somewhere. 0. I think it's on this one. Okay, that's going to give me a -16 right there, because it's this times this times this. So down here, I'm going to have a 24. And then what I do is I subtract this minus this, which gives me my answer of 10. So you multiply up, you add, and then you subtract. Or you can put it in the calculator and select the determinant button and get the same answer. The inverse of a third order matrix has to be done on the calculator. So you're going to put the matrix in, and then you're going to select that matrix and then hit that button x to the -1st power. The last thing that we did in this chapter was solving section 2.6 has to do with solving systems of a linear equation. Very first thing we're going to do is we're going to put everything in order so that we can graph it. So I'm going to solve this one for y. So I have a -2x plus 12. I'm going to divide through by 3. So I'm going to get a -2/3 x plus 4. So I am going to graph these 4 equations. I've got to put this one in the right form too. So -x plus 5. Okay, so let me do my real quick sketch graph here. And so I'm going to graph this one in blue. So I have x is greater than 0. Now that is a vertical line through the y-axis. So x equals 0 all along this line. I'm looking for greater, so I'm looking to the right of it. This is going to be y is greater than 0, so that is a horizontal line through 0. And it's going to be greater than. So right now I'm looking at the first quadrant. This will be this graph. I'm going to go up 5. 1, 2, 3, 4, 5. And then I'm going to go down 1 and over to the right 1. And it's less than this. So right now I'm looking at this triangle right here. So I have y is equal to negative x plus 5. It helps to color code it and to write the equation next to it. And then in red, I'm going to do this last one. I'm going to go up 4. 1, 2, 3, 4. And then I'm going to go down 2 and over to the right 3. So down 2 and over to the right 3 is approximately right there. And I'll do that equation. Now notice that my line is not straight, so if I made it straight, it would kind of be like that. So ignore that. Okay, so the red is y is equal to negative 2/3 x plus 4. Now, if you'll notice, I have got this section right here. Okay, so I've got the intersection. Now this probably is not on that line, so there's a point here, and then there would be a point here, and then another point on the green. So let's first see what the intersection between the red and the green is. So I'm going to put those two equations into my calculator. So I have y equals negative x plus 5. Okay, this one. And then I have the red one, which is y equals negative 2/3 x plus 4. And then I'm going to graph these and find their point of intersection. And let's see, that's going to give me, okay, that's the point 3, 2. So they actually cross up here a little bit. Actually, that wasn't too bad. So let's say they cross right there. Okay, that is the point 3, 2. And then I've got the green line that comes down and crosses over with the purple. So that's when y is equal to 0. So I can put that in my calculator if I want. And I'm looking for the point of intersection between the green and the purple, which is right here. So I do second calculate, come down to intersection. And it tells me that is the point 5, 0. So I have a point 5, 0 right there. This is the point 0, 0 because it's at the origin, and then this one will be the point 0, 4. So I have 4 points. I'm going to take those 4 points and I'm going to make a table out of them. So I've got 0, 4, I've got 0, 0, I've got 3, 2, and I've got 5, 0. And I'm going to plug these in to the constraining equation, which is up there. So 2x plus y plus 1. So that's 2 times 0 plus 4 plus 1, 2 times 0 plus 0 plus 1, 2 times 3 plus 2 plus 1, and 2 times 5 plus 0 plus 1. This one's going to give me a 5. This one's going to give me a 1. This one's going to give me a 9. And then this one would give me an 11. Let's make sure that's right. Okay, so what I have here, the minimum point is a 1. and that minimum point is at 0, 0. The maximum point is 11, and it is at 5, 0. So that's what they're asking you for. It helps to do this on graph paper, because then you can get your graph exact. So the homework on this is page 120 through 122, 12 through 50 even.